Alright, we are back with another one. So in this video, we will be talking about FUF, which is Fast Furious Fuzzer. So basically it's used for web fuzzing. In this video, I'll be using a module from HackTheBox, attacking web applications with FUF. Quick intro about FUF. So you can do multiple things with FUF. You can do fuzzing for directories, fuzzing for files and extensions, identify virtual host, fuzz for PHP parameters, and first for parameter values. We'll look into it in more detail when we go further. I have already completed this module but thought of recording it. Also, before we get into the actual video, it would be great if you can subscribe to my channel. That really supports me to create more and more. To understand fuzzing, you can think of a website and it has multiple pages, but you don't know what those pages are. We usually utilize predefined word list of commonly used terms for each type of test of for web fuzzing to see if the web server would accept them. Now to understand this, let's say if you go to http hackthebox.eu does not exist. We get an http code 404, which means the page does not exist. But if we go to slash login, we find that we get the login page. Now, if you want to find all the working pages, it cannot be done manually. That's why we use any of the fuzzing tool, and FUF is one of them, and it's one of my favorite as well. We'll look into detail what exactly is a word list in context of fuzzing, but it's very similar to what we have in password-based attacks. This tip is very useful. So if you want to ignore the comments within the word list, you can use a hyphen IC flag, which would basically ignore all the comments within the dictionary. So for directory fuzzing, FOF is pre-installed on your Pwnbox instance. If you want to install it on your own machine, you can use this command apt install fof-y. You can also install it from the GitHub repo. As a new user of this tool, we will start by issuing the fof-h command. We'll be going through some of these options while doing this module in the further stages. But on a high level, suppose if you want to define a header, you can do it with -h. You can define HTTP methods, you can define cookies, you can define post data, you can do a recursive scan. So suppose you have found a directory and you want to get inside that directory, you can use this hyphen recursion flag which would scan recursively. Now coming down to directory fuzzing, how exactly we do it. In FUF, you can use the switch -w to define the word list, and to assign a keyword to that word list you use a colon symbol. In this case fuzz was assigned, but you can use any of the keyword for assigning it to the dictionary. Now this keyword is useful when you actually fuzz the website or the URL. You will place this keyword where exactly you want to inject the words from the word list. So now let's start our target in the question below and run our final command on it. So for that, I have already run the Pwnbox instance. Let's see what's the question. In addition to the directory we found above, there is another directory that can be found. What is it? So we'll run a basic FUF scan here for directory fuzzing, and I will be using the same word list, and I will mention the keyword was here. Also, I have not assigned the keyword to dictionary, so let me do that. And now if I run this command, it has started the job. The last phase we saw we can ignore all the comments, so let's do that as well. We ignore all the comments, and there we go. It's fast and quick. We already have the other page which we need for this exercise, but yeah, as you can see, there are almost 20,000 requests per second, so it's a fast tool and you can do many more things with it. Now let's go to the next one, page fuzzing. We now understand the basic use of FOF through the utilization of word list and keywords. Next, we will learn how to locate pages. In the previous section, we found that we had access to slash blog, but the directory returned an empty page. We cannot manually locate any links or pages, we will once again utilize web fuzzing to see if the directory contains any hidden pages. However, before we start, we must find out what type of pages the website uses, like .html, .aspx, .php, or something else. So, as I said, you can do fuzzing for extensions, you can fuzz directories, you can fuzz for virtual host. And in this one, what we'll be doing is we'll be identifying the right extension for the page. Will be using this word list web extensions.txt. If you don't have checklist on your Kali machine, you can install checklist word list just by using the command apt install checklist -y. Now we can rerun our command, carefully place our first keyword where the extension would be after index. We do get a couple of hits, but only .php gives us a response with code 200. So that's great. Now, apart from that, for the page fuzzing, we'll use the same word list as before and now fuzz the actual page. We do get a couple of hits. Both have an HTTP code 200, meaning we can access them. Index.php has a size of 0. Now let's see what the question is in this one. Try to use what you learned in this section to fuzz the /blog directory and find all pages. One of them should contain a flag. What is the flag? Now we already know the extension which would work on this page is .php. Now what we'll try to do is we'll try to find the flag using the same command provided in the module, and I will change the server IP port to the machine IP, and let's see what we get. I missed the iPhone IC flag, so let me mention that we have found something here, home.php. Let's see if this works. There you go, and you have the flag in here. Perfect. Now we'll move to the next one, recursive fuzzing. Basically, some websites may have huge list of subdirectories. So in FFUF, we can enable recursive scanning with the hyphen recursion flag, and we can specify the depth with the hyphen recursion depth flag. Now let's see what we have here. Let us repeat the first command we used, add the recursion flags to it while specifying .php as our extensions, and see what results we get. So they used fuff-w, the word list, and they are trying to scan the base URL with recursion depth of 1 and extension as .php. As we can see, this time the scan took much longer, sent almost 6 times the number of requests, and the word list doubled in size, once with .php and once without. Still, we got a large number of results, including all the results we previously identified, all with a single line of command. Now let's see what do we have in our question. Try to repeat what you learned so far to find more files directories. One of them should give you a flag. What is the content of the flag? So if we go back to the machine and define the -ic flag, as you can see, it found the blog directory and the forum directory. So it would be digging down further in both these directories. As you can see here, the first keyword has moved to /forum/first/blog/first, and it would give us back the results from inside those directories. We do get some initial hits, but this is from our last question, so the flag shouldn't be here. Inside the forum directory, we see something interesting, which is flag.php. There you go. Alright, we'll move to the next one now. DNS records. Once we access the page under /blog, we got a message saying admin panel move to academy.htb. If we visit the website in our browser, we can't get into the server at academy.htb. This is because the exercises we do are not public exercises. So browsers only understand how to go to IPs, and if we provide them with a URL, they try to map the URL to an IP by looking into the local /etc host file. You can think of slash etc host as your local DNS. Now, if I copy this command and put an entry of this in our local DNS server, so for that, I will go to my machine, paste this command, change the server IP, and now try to access academy.htp 32251. However, we get the same website we got when we visit the IP directly. So academy.htp is the same domain we have been testing so far. We can verify that by visiting slash blog slash index.php and it should be HTTP. Yeah, you can see we get the same flag. Now moving on to the next one, subdomain fuzzing. In this section, we'll learn how to use FFUF to identify subdomains for any website. A subdomain is any website that underlies a subdomain is any website underlying any other another domain. A subdomain is any website underlying another domain. For example, photos.google.com is the photos subdomain of google.com. So let's run a scan and see if we get any hit. In our case, we would be using a shorter word list, which is subdomains top 1,005,000.txt. If we want to extend our scan, we can pick a larger list. Instead of voice.inlandwrite.com, I will use academy.html. There we go. We see that we do not get any hits back. Does this mean that there are no subdomain under academy.html? No, this means that there are no public subdomains under academy.html as it does not have a public DNS record as previously mentioned. Even though we did add academy.html to our local DNS file, we only added the main domain. So when FUF is looking for another subdomain, it will not find them in etc host. So try to understand it in this way. Let's say there is a subdomain under academy.html abc.academy.html, but it does not resolve to the same IP what we actually have inserted in our local DNS file. So there is a possibility that we do have more subdomains, but as there is no public record for it, we cannot find it. Now let's look what we have in the questions. Try running a subdomain fuzzing test on inlanefreight.com to find a customer subdomain portal. What is the full domain of it? I will use inlanefreight.com. All right, we can see there are multiple subdomains available for this particular domain. To find a customer subdomain portal, so in this case, it would be customer.inlanefreight.com. Alright, we'll go to the next one now. Virtual host fuzzing. As we saw in the previous section, we were able to fuzz public subdomains using public DNS records. However, when it came to fuzzing subdomains that do not have a public DNS record or subdomains under websites that are not public, we cannot use the same method. In this section, we'll learn how to do that with virtual host fuzzing. The key difference between virtual host and subdomain is that a virtual host is basically a subdomain served on the same server. So as I was explaining, if you have abc.academy.htp which resolves to the same IP and port, that would be considered as a virtual host. To scan for virtual host without manually adding the entire word list to our etc host, we'll be fuzzing HTTP header, specifically the host header. To do that, we can use the -h flag to specify a header and we'll use the keyword within it. We see that all words in the word list are running 200 OK. This is expected as we are simply changing the header while visiting academy.htp. So we know that we will always get 200 OK. However, if the virtual host does exist and we send a correct one in the header, we should get a different response size. As in that case, we would be getting the page from that virtual host, which is likely to show a different page. So far, we have not been using any filtering, and the results are automatically filtered by default by their HTTP code, which filters out code 404 not found and keeps the rest. FUF provides the option to match or filter out a specific HTTP code, response size, or amount of words. We can see that with FUF-H. In this case, we cannot use matching as we don't know what the response size from other virtual hosts would be. We know the response size of the incorrect result, which as seen from the test above, is 900. So if I go back here and see, all of these subdomains give me the same size, just 986. So if I want to exclude this, I can filter it with the -s switch. So if I run the same command, but this time with 986, we just find the virtual host where we get different size. So test and admin are two of them, as you can see here as well. We'll add the entry for admin.academy.html. Now if I try to visit the web page, I can see a blank page in here. We see that we can access the page, but we get an empty page, unlike what we got with academy.html. Therefore, confirming this is indeed a different virtual host. Now let's see what we have in the question. Try running a virtual host fuzzing scan on academy.html and see what other virtual host you get. What other virtual host did you get? So initially when we ran the scan, we found there is another virtual host which is test.academy.html. Now we will move on to the next one, parameter fuzzing. So if we run a recursive of scan on admin.academy.html, we should find http admin academy http /admin/admin.php. If we try accessing the page, we see the following. That indicates that there must be something that identifies users to verify whether they have access to read the flag. We did not log in, nor do we have any cookie that can be verified at the backend. So perhaps there is a key that we can pass to the page to read the flag. Such keys would usually be passed as a parameter using either a get or a post HTTP request. Similarly to how we have been fuzzing various parts of a website, we will use FFUF to enumerate parameters. Let us first start with fuzzing for GET requests, which are usually passed right after the URL with the question mark symbol like this. So before actually going to the exercise, if I try to access this URL, we see we don't have access to read the flag. So we'll try to fuzz the parameter. We see size 798 as common, so we will filter out the results. -fs798. Alright, looks like we have found the parameter. Next, we go to the website back again and try user is equal to 1. This method is deprecated. We do get a hit back. Let us try to visit the page and add this get parameter and see whether we can read the flag. This method is deprecated. This is what we see. As we can see, the only hit we got back has been deprecated and appears to be no longer in use. Let's see what's there in the question. Using what you learned in the section, run a parameter fuzzing scan on this page. What is the parameter accepted by this web page? So that's user. Now, the main difference between post request and get request is that post requests are not passed within the URL and cannot simply be appended after a question mark symbol. Post requests are passed in the data field within the HTTP request. Check out the web request module to learn more about HTTP request. So let us repeat what we did earlier, but place our first keyword after the -d flag. So to send the post data with FFUF, we can use -d flag as we saw previously in the output of -h. We also have to add -x post to send post request. Again, we see 798. So we will filter out the results for this size. Alright, we do see two parameters, ID and user. As we can see this time we got a couple of hits, the same one we got when fuzzing get and another parameter which is ID. Let's see what we get if we send post request with the ID parameter. So we'll use curl command for the same. We don't get much in here. Invalid ID is the response. As we can see, the message now says invalid ID. Go to the next page. After fuzzing a working parameter, we now have to fuzz the correct value that would return the flag content we need. So we'll create a dictionary file. And this time, instead of fuzzing the parameter, we will was the key. So change it to ID is equal to fuzz, and we will use the dictionary we just created. Okay, and let's filter out 768. We found 73 as one of the response. Let's send that curl request again with the ID as 73 this time, and we do get the flag for this exercise. So yeah, that was it for FUF. If you want to try it yourself, I would suggest doing the skill assessment part by yourself. It would help you to identify if you have learned FUF completely or not. This is a free module, so what I'll do is I'll put a link in the description section so you can try it out. Thank you so much, and I'll see you in the next one.